Welcome to Learn Animatronics. Those are a few of the projects that I've made in the past. And if you struggle with taking a microcontroller and adding it to your projects with servos, motors, LEDs, then this video series is for you. I'll take you right from the start, ground level up, and show you how to add electronics and mechanics to your projects, kind of like I did with Bones over here. And at the end of the video, I'm going to show you how to take just a simple blinking LED to another level. In this video, we're going to look at designing circuits, programming an Arduino, and then applying it directly to animatronics. So let's get started. Well, here's my setup. I've just got this longer breadboard attached to this Uno, and they're just kind of hot glued onto this piece of wood. It's actually, mine's laser cut, but you can just glue on a piece of wood, and that's totally fine. In your kits, you're probably going to get something like this. It's just an Uno attached to a breadboard, and that's totally fine for our application. So I'll show you now a few of the parts that should be in your kit to accompany this video series. Well, here's a quick confession. Using an Arduino to blink an LED is probably overkill. There are much better ways to do that. Take a look at these pre-wired LEDs that you can buy. They are LEDs that come with a resistor. They are multicolored, multi-voltage. They even flicker. So that's probably your best bet if you just want to blink some LEDs. But the reason we're doing this blinking on an Arduino today is that you learn how to create code, how to modify code, and upload code so that we can get into more complicated projects in the future. Okay, even though you may not have any of the parts needed to do some of the projects already, that doesn't matter because we're going to be using a program called Tinkercad Circuits to teach you all about Arduino's programming, designing circuits, and it's an amazing program and it's free, so let's check that out. If you go to tinkercad.com, you will be able to sign up for an account. It's a totally free account, so I'll let you do that on your own. When you have downloaded or signed up for Tinkercad, you will be at this window. The first thing that you want to do is click over here on the right-hand side and go to Circuits. Here we have a myriad of a bunch of parts over on the right-hand side. Now, Tinkercad is all cloud-based, so it automatically saves everything for you. If you take a look up in this top left-hand corner, it's already titled this first project of yours. And it's kind of a weird project name, so we don't want that. We're going to change that first off. So we're just going to click on there. We're just going to put maybe blink and LED and hit enter. And that is now the name of our project. And you can always get to those projects by clicking back up here, and it'll go to all of your saved stuff on the cloud. So let's take a look at these parts over here on the right-hand side. You can see that these are the basic parts. And if I click on here, I can go to all parts, and more parts will show up over on the right-hand side. For now, we just want the basics. The only thing we're going to pull out right now is an Arduino Uno. So we're just going to click and drag that over to our main window. This is what an Arduino Uno looks like. It's got a USB port that when you plug in to your computer, it'll provide power to this thing. This little on LED will light up, and whatever program is already on here, if there is one, will start to function. Now, programs in the Arduino world are called sketches. So we'll refer to them as sketches. So that's something that you should know about. If you ever wanted to upload a program to your Arduino and then unplug it and have it as a standalone device, you can plug in a power pack over here into this DC jack, and it will also power your Arduino. So that's just another way to power it up. A couple things about an Arduino. You can see that there's a bunch of numbers up here. and that refers to these pins. So these are all called pins, and they go from D0, which is a 0 here, to D1 all the way up to D13. And then we have a ground. You also have some squiggly lines on some of them. We'll talk about that at a later date. So there's pins up at the top, but there's also pins down at the bottom. We have A0, A1, A2, all the way to A5, and we're going to learn about those as well. And then we have a VN. So that's actually another way to power your Arduino. We're not going to power it up that way right now, so let's just ignore that. But we have two ground connections. These two ground connections are also the same as the ground connection up here, so they're all attached to each other. Just you have one on that side and two on this side. You have a 5-volt supply, which means that if you've got power coming in here, this can put out 5 volts to some really small parts. Arduinos aren't meant to power things, they're meant to control things. So we'll talk about power in just a little bit. So anyways, those are all of the pins on an Arduino. Now, each pin can be an output pin or it can be an input pin. So if I click on here and I attach a wire to there, that means that what's coming out of pin 7 right now could be an output, and it can go to something like it could go to a servo or an LED or a DC motor or something like that. So the pin mode for pin 7 would be output. Likewise, you could also have something attached to this. For instance, you could have like a light sensor here. There's a light sensor, and you could have that go to pin 7. And now pin 7 is no longer an output, it's an input. So pin 7 can have two modes, an output or an input. And you could do that with all of these pins. And the way you let Arduino know that it's an output or an input is you do that in your sketch. The really cool thing about Tinkercad circuits is that you can actually create a code, put it on here, and watch it do its thing by attaching parts to it. And if it works here, it will work with a real Arduino. Now, how do you put a program on here? Well, on a real Arduino, you'd have a program called the Arduino IDE. We'll get to that in a minute. But for Tinkercad, you go up to this code button here. So we're just going to click on that. And notice that the code looks like they're like blocks of writing. Well, this block type coding is one way to program an Arduino, but we're not going to use that kind of programming syntax. We're going to click here and we're going to go down to text, and it'll say, are you sure you want to convert all this to text? Just say continue. And now all of those blocks have been converted into a text that looks like this. So that's where we're going to go next. And notice that this Arduino that we pulled out already has a sketch on it. Let's take a little trip down digital analog lane and tell you what the difference between these two things are before we get into the code. Digital just means off, on, off. So directly, there's no variation in between them. And you can think of it as an on or an off, or a high or a low, or a 1 or a 0, or a 5 volts up here, 0 volts down here, and eventually we'll talk about 255 or 0. The other type of signal you can have is an analog signal, and that goes from totally off to totally on, but there's variation in between. So it's more like a dimmer switch, so it can go from off to a little bit more power, a little bit more power, so it's getting brighter and brighter and brighter till its maximum brightness. And that's the difference between digital and analog. We'll be talking about that a little bit today, and then further on down in the next set of videos. Let's take a look at the Blink sketch in Tinkercad that comes equipped with that Arduino. I'm going to make a few changes to it here, and then we'll re-upload it. Even though this sketch works, it's not the greatest sketch. There's a few things here that for syntax that I don't really like. So I'm going to make these changes, and hopefully you can learn from that. And down the road in your further sketches, you'll be able to stick with these changes to make it a little bit better for yourself. So the first thing is notice that there's these two / lines. Now / means that anything after that on that line, Arduino is going to ignore. It's just a note to a human being. We don't really need them in the sketch, but they're great to have comments in sketches on lots of lines, especially if you want to write a note to yourself in the future to remind yourself, what was really happening in that sketch. So we're going to just take that out. We're going to highlight that, delete it. We're going to delete that one. And we're going to delete this one just to clean up our code a little bit so that it's easier to see. Now, the reason I put a space here is to help identify two major parts of a sketch. So we've got the void setup and we've got the void loop. Those two parts of a sketch are called functions, and you need to have them in every sketch. And there's particular things that go in each of these different functions. So the void setup just sets everything up. So it starts with void and then the word setup, that's the name of it, and then open and close brackets. Everything that is part of the void setup go between these two curly brackets. And in this case, we only have one thing that's written for this sketch. The loop, however, has like about 4 lines here. So we're going to find out what those things actually do and what they're used for. Sometimes there are things above the void setup, and there's going to be in this case because we're going to change this code a little bit. An Arduino sketch starts from the top, does line by line, goes all the way down. Once it gets to the loop, it knows it's in the loop, and everything from this curly bracket to this curly bracket is going to happen over and over and over again repeatedly until you unplug your Arduino. And it's always going to be on that Arduino on that microchip, so you don't have to worry about it being erased or anything. So that's basically how it functions. We have a little name here called LED built in. So that's a little LED that's built in onto our Arduino, and we're going to change the name of it in just a second here. I'm just going to go up to the top. I'm going to hit enter because I want to put another line in. So let's do that like right here. First of all, we're going to call it int LED pin equals 13 semicolon. So this happens before the setup, and what it is it's a variable. So variables are very useful in Arduino sketches because it helps you not just organize things, but to change things later. So a variable always requires 3 things: what kind of variable it is, and in this case, int stands for integer. So it's going to be a number, we know that. The other thing you have to tell Arduino is what's the name of that variable. And in this case, the variable's name is LED pin. So it's a pin that the LED is on. Now you could call this anything you want, but it's better to name things appropriately so that you actually remember what they're for. And then we're going to say that that LED is going to be attached to pin 13. Wherever you want that LED pin 13 to be in your sketch, like right here, we're going to give it its proper name, LED pin. And down here, we're going to change LED built-in, LED pin, and one more time. So if you were creating this sketch, you would do this right away at the beginning. So here's what happens. The sketch starts and it says there's a LED attached to pin 13, and it's called LED pin. So whenever you see LED pin now, it's going to refer to pin 13. If you later on wanted to change that pin and say, hey, I can't use pin 13, I really want to use pin 2, it's easier for where it is in the circuit or what have you, you can just change this number 13 to pin 2 or 3, and the sketch knows to change it throughout. So we start at the top, work our way down, and the first thing we run into in the void setup is pin mode. So pin mode, let's take a look at that and find out what's going on here. Remember, pin mode means the mode of the pin, whether it's an input or an output, and you have to tell it that in the sketch. So in brackets, you're going to put LED pin, so pin 13 is an output, and output has to be in all caps, plus the semicolon at the very end. That's pin mode, and then it comes down, and then we start our loop. So it's going to digital write, so digital means on or off, remember. It's going to digital write LED pin, so pin 13 high, so it's going to turn it on. Then it's going to delay 1,000. And by 1,000, we mean 1,000 milliseconds. Milli means stands for 1,000, so it really means that it's delaying 1 second. And then it's going to digital write that LED pin, so pin 13, off and wait for 1,000. So wait for 1 second. So it's going to turn it on for a second, shut it off for a second, go back up to the top, do it over and over and over again until you unplug your Arduino. So what we're going to do now is we're going to take this sketch, select it all, copy it, and we're going to paste it into Tinkercad and check it out. Here we are back in Tinkercad, and what I'm going to do now is just select this old code and Control V, paste in the new code, and let's test this out, see if it's working properly. So I'll just go to Start Simulation, and sure enough, everything's working correctly. So now that we have our new code in here, or say that you've created a code that you really like and you want to copy it, the easiest way to do that here is to go to Stop Simulation, and there's a download button right here. So you're going to download the code. It'll go to your downloads folder. You can open it up from there in the Arduino IDE. So let's click download and check that out. Before we look at the sketch we downloaded and put it on a real Arduino, we need to make sure we have the Arduino software on our computer. So if you go to arduino.cc, you can find it there. Just click on software and then select the platform that you need to download from. So I have a Windows 10, so I'm going to click on there. This gives you a chance to donate, which is probably a good idea. And then you can download and have that on your computer. So here's the file that was downloaded from Tinkercad to the downloads folder, and notice it's sitting right here. It says blink and LED. Now if I try and open this, something's going to happen. It's going to say, wait a minute, this file needs to be in a folder with the same name. So that's the way Arduino organizes itself. It puts every file, every sketch basically, into a folder with the same name. So if I just say OK, it'll do that right here. It's actually opened up the file for me in the Arduino IDE, but I'm going to close that. You can see now that it's in a folder, and if I open that, it's got the same name there as the folder. So that's something to expect when you open up a sketch for the very first time. Here we are in the Arduino IDE, and a couple things I want to point out to you. Let's move this over a little bit so you can see it. We've got two buttons that we need to talk about. The first one is your verify button. So when you click on this, notice what happens down at the bottom here. It'll say done compiling. If everything's working okay, that's a great message. Otherwise, you might get a big red bar here saying that there's something wrong with your code. You'll have to fix that. The other one is your upload button. We'll get to that in just a second. There are two things you need to do in Tools. Remember, you have to make sure that you've got an Arduino Uno selected. And if you don't, you go to Arduino AVR boards and select an Uno. It needs to know that for sure. The other thing you need to do is make sure that in Tools, you have selected your right COM port. So the port that I have right now is COM port 4 because it says my Arduino Uno is attached to that. So make sure you've selected that before you do an upload. So notice right now that the LED on the Arduino is not blinking, so the sketch is not on there. So let us click upload and watch these little lights. They'll just blink rapidly for a second, and then now we've got a blinking LED. So everything is working, and now we can play around with the code a little bit, and then we'll move into a little bit more advanced code for you. Time to get a little bit more technical with some parts and some code. So I'm just going to hide the code for a minute, and we're going to make our Arduino look a little bit more like the one that you're going to have in your kit. So we're going to go over to Breadboard and bring this breadboard over, and that's similar to what you're going to have there. Now I just want to talk to you a little bit about these breadboards. It's a way to add parts to the Arduino just next to it so we can wire things up. Notice that this rail here, this is a negative rail. They're all attached to each other along this rail. So that's a good negative rail if you want to connect things to negative. That's a positive rail. And we have a mirrored thing like that on the bottom. Now the bottom rail here, negative, is not attached to the top one. They're independent of each other. And then we have these rows. So each row is connected to their own holes in this row. So there's row 2, row 3, row 4, and so on. And then we have a bridge in between the breadboard that separates the top half from the bottom half. So this is a great way to just connect some of these parts over here onto here and hook them up to an Arduino. We know we've been blinking this LED on here. That LED is actually attached to pin 13. So that's why we put LED is on pin 13 to make that blink. Now what we're going to do is we're going to grab another LED. So this LED here is red. And when we let go, we can see that it's red, but I could change the color of it to yellow or green, whatever you want. Let's leave it green for now. And if I hover over these leads, one says cathode, one says anode. So this is the negative end, that's the positive end. And I know that, so I'm going to plug that into any one of these holes here, and notice it all lines up and just snaps into place. Now, we have been using pin 13, but what I want to do is I want to use a different pin. So let's try pin 7. So we're going to take a wire from there, and so I'm just going to drag a wire and hook it up to, you can see this row is all attached to that anode, and click on there, and I've got that attached. I can change that color up here to red if I want, or any color that I want it to be. And now what's going to happen is I'm going to have to tell the Arduino code that pin 7 is an output, and it's going to go out here, put power out here, start the LED up, but it needs to have a ground wire. So we're going to put the ground wire from there all the way to this ground over here, and usually ground wires are in black. So we have a complete path. So power will come out, go through the LED and into there. Now let's try it. Okay, not working because pin 13 is still active. So let's go to the code, and we're going to change this now, and that's why it was important to have a variable. We're going to change that to 7 and try that. So we're going to start the simulation, and boom, we have a blinking LED on a different pin. Unfortunately, we have this warning symbol showing up. So if I click on here for a second, yeah, there we go. It's hard to see because it's flashing really quickly, but it says that the current through this LED is too much. It's going to burn out. So if I actually had that on an Arduino, it would burn out your LED. So let's stop that because we don't want that to happen. All LEDs need to have a resistor in line with it. Okay, and the way we're going to do this is we're just going to pull a resistor out, and all a resistor does is it slows down the amount of, lessens the amount of current that goes through here. And resistors are all color-coded. So let's just take a quick look at that. So you'll find that on a resistor, you'll have a gold or a silver band up here. That's the back of the resistor. The front of the resistor are the other colors that are closer to each other. And each color means something. It means a number, actually. So if I click on here, we can see that this resistor is brown, black, red, and it is a 1 kilo ohm. So kilo is 1,000, so it's a 1,000 ohm resistor. I know that brown is 1, black is 0, and red is 2. So that means what you do is you take a look at a color chart, and I'm going to show you that right now real quick, just so that we can see how these are actually read. Here's a color code chart for resistors. If you take a look over here, red is a 2, so it's a 2 right here. Brown is a 1, brown is 1, so it's a 21 something. And then we have an orange after this, so orange is 3, so that means there's going to be 3 zeros. So this is a 21,000 ohm resistor, or a 21 kilo ohm resistor, because kilo means 1,000. So 2 ways that you can write that down, or register that resistor as a 21,000 or a 21 kilo ohm resistor. So what I have here is a 1 k ohms or 1 kilo ohm resistor, and that's too high a value for what our application is. I can tell you right now that for applications like this, 220 to 400 ohm resistors is plenty. There's actually proper ways to calculate the correct value for this resistance. We're not going to get into that right now, but what we're going to do is we're going to change this one. So we're going to just click on it, and we're going to say I want a 220, because I know 220s are common resistors that you have in kits, and we have to change this to ohms. And notice that it's changed its colors to red, red, brown. So that's 2, 2, and 1, 0. So that's 220 ohms. So I want to put that in line with this LED, but I'm going to move it. I'm going to actually rotate it. So I'm going to click on it and then hit the R on my keyboard. Every time I hit the R, it rotates a little bit, and I can put it in line with this. So far, there's nothing on here, so I want to take this guy, click on here, grab that, and put it over here or anywhere along here. And now what's going to happen is you're going to have the power come out, and then it's going to go in line with this resistor. It's going to lessen the amount of microamps that are going to go to, or milliamps that are going to go to the LED, and then out here. And we're going to try that. We're going to start simulation, and bam, there you go. It works better. There's no warning that, hey, the LED is getting too much current. So we are fine. So that's basically what we're going to do, is we're going to try that out on our real Arduino and see how well that works. All right, I have an LED here, and notice that this LED has a short leg and a long leg, okay? Now, there's no labels that say anode and cathode on here, but I do know that on LEDs, the short leg is the cathode and the long leg is the anode. So I'm going to flip it around like this and put it into my breadboard. Anywhere I want there, I'll just bend it over so you can see it a little bit better there. And then I have my resistor. This is a 220 ohm resistor. I'm just going to bend that over, and we're going to go from pin 7, just like in Tinkercad. We're going to go directly into that line. So it comes out of here, along that line into the anode, going to come out the cathode. So I'm going to use a black wire here and go into ground. All right, so no blinking so far. Let's go to the code, and we're going to change this in the code to pin 7. And we're going to re-upload. There we go. There we go. Now we've got LED on pin 7 is now blinking. So you've now changed the code, made a short little circuit here. It's just a simple circuit. And now you know how to do that. So you can add more LEDs. You can change the blink rate, which we're going to do right now. Let's just for fun do that. So let's go down to here, and let's change this to say 150, and the one below it. Let's do that as well. 150. Upload the code. Let's see how this guy changes here. There we go. All right. So next, we're going to take just a simple blinking LED, which is great for a lot of projects, and we're going to make it into a random blinking LED. I've changed the title of this to Blink an LED Randomly, because what I call this is artificial intelligence. It kind of looks like it. It's really not, but it randomly picks numbers. So it kind of looks like your LED is choosing its own values. And you can do this with servos and DC motors to make your animatronics appear like they're thinking on their own. So what we need to do to generate this effect is to introduce a new integer, and that's going to be a name called random number. And we're going to use that name further on down in the script, so that's why you need to declare it up above, otherwise it won't know what kind of a variable it is. In our setup, we're going to put in a little thing that Arduino already knows about, random seed and analog read brackets A0 brackets semicolon. Okay, so this looks a little bit weird. The random function can still work without this line, but basically what it does is it helps seed the random number we're going to generate later. And it looks at the analog pins, so A0, A1, A2, A3, those ones there. It just looks at one of them, pin A0. And sometimes that pin, if you don't have anything connected to it on an Arduino, sometimes it's a floating pin. So it floats high or low. It's never always exactly the same. So It looks at that, and that's going to help decide if it's high, it's going to help generate a specific kind of number, and if it's low, it's going to be a different number. Put that in to help you generate your random number. In the loop, we are going to actually make the number here. So we're going to go random number, that's the one that we came up with a name up above, is equal to random, and then you can pick from what low value to what high value you want your random number to be generated from. In this case, I'm going to be putting a number between 50 and 800 into my delays. You can do it lots of different ways. You can make this a 1 and or a 0 and put them into your highs and your lows if you want, but I just chose to do it this way. So let's see how this works out. So this is either going to be 50 milliseconds, 800 milliseconds, or any of the milliseconds in between. And what we're going to do is we're going to replace the 1000 with the word random number, and this one as well, random number. So when the sketch gets to here, it's going to pick a number between 50 and 800, and it's going to turn the LED on, and that's going to take that number and stick it in here. So the delay is going to be whatever it chose. And then it's going to put it low, put the LED low, so shut it off for the length of time that that same random number was generated. And then it's going to go up to the top, and it's going to pick a different random number, and so on and so on. So what we're going to do is we're going to copy this code, and we're going to go over to our Arduino and try this out. We're back at our Uno, and it's just flashing at a constant pace. So think about 120 on, 120 off. What I'm going to do now is I'm going to upload, first I'm going to paste in our new sketch. Everything looks good. We've got it set to pick a number between 50 and 800 for the delay. Before we upload the code, I'm going to show you a different LED. This is a jumbo LED. Just puts out a bit more light. It's a lot larger. Stick that guy in, so you hook him up the same way. You need a resistor. So there he is. Let's upload our code and see what that looks like with the jumbo LED. So hit upload, verifying, uploading, done, boom. Okay, so now our LED is acting a little bit differently. The amount of time it's on and off varies based on a number between 50 and 800. I could change that quite easily. I could just go down to here and say, let's make that 500 instead, re-upload the code, and see how that affects it. So it's going to be on and off a lot more frequently. So you can use this code, this random code, in servos and DC motors and all sorts of things to make your animatronics seem like they're thinking on their own. That's basically what I did with Bones, my little skeleton companion. He moves his head randomly, and the time between his movements is random and things like that. So this has been really great. You've learned how to use Tinkercad, how to upload code on Tinkercad and onto an Arduino Uno. You know how to modify the code. You know what a lot of the terminology is already. You're set up for all of the things we're going to be doing. Now let me show you how I used blinking LEDs in my R2-D2 dome. Well, I hope you enjoyed learning about Arduinos and how we can use them to control our animatronics. In the next lesson, we're going to look at these individually addressable LEDs. That's how I made this maker sign above me. Maybe in the meantime, take a look at these tiki drummers. They are 3D printed and operate with servos. That's an area we're going to get into a little bit later on. Until then, God bless you, and we'll see you next time on Learn Animatronics.